All right. So, hello and welcome everyone. Welcome all of you to this amazing platform of Tutee Learning. So, we are live right now. So, I hope I'm audible to all of you. Right. So, let's start the chapter of vectors. Right. So, as of the previous discussions, we have been looking into the vector algebra. So, this is the lecture number 7 for vector algebra. And today, we will be discussing about some questions on vector algebra regarding dot product, and with that we'll try to understand the idea behind cross product, right? So I welcome all of you to this class, and if you're new to this particular platform, please subscribe to the channel and hit the bell icon, because every day on this particular platform you can see that live lectures are basically being happening, right? So it is not only mathematics, it is chemistry, it is physics that is happening up, and also we have our biology lectures going on simultaneously on the NEET platform, right? So all those particular thing has been going on. So please take the good use of this particular lecture series that has been provided for free on YouTube, so as to understand the things in details, right? So with this, let's discuss about today's topic of dot product, right? And if you are really interested into getting one-on-one online coaching, or you want to get your mentorship, or you have some doubt and you want to get your doubt clear, you can definitely contact us by the number that is given on the description box, as well as it is also mentioned in the live chat. Okay, so please take good advantage of all that, and with that, you'll be ready to discuss, right? So let's start with our lecture number 7. And today, let me discuss about, first of all, so in the previous class, we discussed about how to find out the angle between two vectors, right? So we understood how to find out the angle between two vectors by using the concept of dot product, right? Similarly, we also saw another geometrical implication, that is the projection, right? So we learnt about how to do the projection of two vectors, right? Or if I want to project one vector onto the another, right? So this is what we have learned in our last class, right? Now, along with this projection thing, there is one more type of question that is basically being asked, that is basically the component. So sometimes in the question, it is also asked about the component of the vector, component of the vector along and perpendicular. So this is a sign for perpendicular to the line. Okay, sometime this types of question are also being asked to find out the component of the vector. So in the previous class, we have learned how to find the component of the vector. However, in this question, we'll try to see how can we write the vector in terms of those component, right? So how we can write a vector parallel and perpendicular to that particular given vector. So we will try to use this particular idea of projection that we learned in our previous discussion. So let's try to see that what I'm trying to talk in this question is that, let's say this is my A vector. So this is the given line which I have over here, and I have another vector B, right? Now I have to mention the vector B as two components, and those two vectors should be, one vector should be parallel to the A vector and another will be perpendicular to it, right? So I have to resolve this A B vector in terms of two vector components. So I have to resolve this B vector in terms of two vector components such that one of them is parallel to the A vector and another is perpendicular to the A vector. So in order to do that, we have learned in our previous discussion. So if I do the projection, so what I've seen that this particular length or the component of this projection was nothing but mod of B into cosine of theta, which is nothing but taking the dot product and dividing by the vector of mod of vector A, right? So we have seen this in our previous class. Now along with that, we have already seen that how we can write this particular magnitude. So the magnitude of the component which is perpendicular to it can be simply given out by square root of mod of B whole square minus B A vector dot B vector divided by mod of A and taking the whole of this particular quantity. So this will represent the length of the component of vector B in the direction perpendicular to vector A. Right. Now, with this particular component, if I am interested to find out that what is my vector, what will be my vector in the direction parallel to this A vector, and what will be my vector in the direction perpendicular to this vector, right? So, in order to come to this particular this conclusion, let me take two vectors like this, such that, so let us call this as B parallel vector, and let us call this as B perpendicular vector. So, if I use the triangle law of vector addition, so what I will get over here is that, so by using the triangle law of vector addition, B parallel plus B perpendicular is equals to B vector, right? Is equals to B vector over here. I hope this is clear, right? So if we do this particular thing and apply the triangle law of vector addition, we will get the following relation as B parallel vector plus B perpendicular vector is equal to the B vector. So if I'm able to find out any of the one vector, then I can represent the other in form of it, right? Because we know a B vector. So what I'm going to do over here is that now in order to write any vector in the direction, we take the help of generally the unit vector. So if I am going to write the vector which is which is which is parallel to the A vector, so this can be given as by some magnitude component multiplied the unit vector of A vector, right? So this particular thing denotes the direction. So the unit vectors are used to denote direction, and this particular component over here will be A vector dot B vector divided by mod of B vector. So this particular part is going to give me the vector which is parallel to the A vector, and this is represented as B parallel vector. So the B parallel vector is given something like this. So once I have this B parallel vector, and by using the triangle law of vector addition, I can say that my B perpendicular vector will be equals to B vector minus A vector dot B vector divided by, I have made a mistake over here. It should be vector A, right? So this will be vector A. So A vector mod of it and multiplied with A cap. So which I can combine and write a simple expression. So mod of A cap can be written as A vector divided by mod of A vector, right? And whole square of it. So I can also write this kind of expression. So this will give me the expression for vector which is perpendicular to the vector which is perpendicular to the A vector. So vector which is perpendicular to the A vector. So by this particular relation, I am able to get the vector which is perpendicular to the A vector, right? All right. So we obtain the two vectors which is parallel and perpendicular to it, right? I hope this discussion is clear. Now we can also extrapolate these particular ideas of vectors to the concepts of physics as well. So for example, if I look into the application of dot product, we have seen that work done by a force on any body is basically given as a dot product, right? So so if I talk about any application of dot product, so work done is a scalar quantity. So the work done by some force, let's say that particular force is given as some Fi. Okay. So work done, so W denotes work done. Okay. So work done by a force is given as this force vector multiplied with the displacement vector. So let us say xi denotes the displacement vector and Fi denotes the force vector. So the work done by a force Fi is given as dot product of force vector multiplied with a dot product with the displacement vector. So you can see multiple examples of such scalar product when you study about different problems of physics. Okay, and even in engineering, this particular thing has been wide scale application. So however, if we understand the basic part of vector multiplication, that is dot product, we can take up to any type of questions. I hope this is clear to all of you. Is this part clear to all of you? Please let me know in the live chat. Krishna Sharma, hi. Iris. All right. So I assume this is clear to all of you. So, all right. So with this part, we are done with discussing about the dot product, right? Now, I can also talk about some of the properties regarding dot product is that now dot product is generally commutative in nature. Okay. So if you talk about the properties of dot product, it is commutative in nature, right? And it has a distributive property as well. Also, also, uh, we can see the associativity property, right? So those all properties holds true for dot product, because again, when you take a dot product, the result is scalar. So therefore, whatever properties is applicable for scalar addition happens to that of the vector dot product as well, right? So with this part, let's discuss about. So we'll take up some questions to understand how to apply this concept. So let's try to understand about another new concept of vector multiplication, that is a cross product. So if you recall, when we were discussing about the vector multiplication thing, we have said that when two vectors are multiplied such that I obtained the relation of the final vector as a vector, then that particular vector multiplication is known as cross product. So let us now study about cross product or vector product, because the result is a vector. So this is also called as vector product. Okay, so let's try to discuss about what is cross product or vector product. Now, if I have, let us say, I have two vectors. Let us say I have two vectors like this and like this. So now, in order to understand the dot cross product thing, we have to also understand the concept of 3D. So let us consider first of all a plane over here. So I'm considering a plane over here, and you can assume the plane to be a sheet of page, okay, or the paper. So let us say that I have two vectors which are lying on this particular plane as a vector and b vector, such that the angle between the vector is defined as theta. Now, depending on the requirement of some other problems of physics, sometimes we need to perform the vector product in such a way that I need to generate another vector which is coming out of plane of this particular plane. So maybe I need to generate a vector which is out of the plane of these two vectors, and they are perpendicular to each other, right? And they are perpendicular to each other. So if I am to generate a out of plane vector, then that is generated by doing a cross product. So when I do a cross product A cross B, this particular thing generates the result for vector which is perpendicular to both the A vector and B vector, and it is out of the plane, right? So this is how we define cross product. So the cross product thing is defined as, by component wise or by magnitude, is defined as mod of A into mod of B multiplied with sine of theta, and then to denote the direction it is given as n cap. Now this n cap, denotes the direction which is given as, so which is basically perpendicular to A vector and B vector, and it is out of plane. So it might have two direction, right? Now we'll try to understand how do we determine the direction of a vector of this cross product thing, right? So we will learn about the right hand curl rule. So we generally use the right hand curl to basically find out the direction of this kind of vector cross product. So what do we do is that, so in the plane we have this A vector over here. So we try to align the fingers of your arm towards the A vector, and in the direction of the B vector, we try to curl our arms or the fingers. We try to curl our fingers since the multiplication is given as A vector cross B vector. So whenever the multiplication is given as A cross B, so first you will put the fingers in the direction of the first vector, that is A vector, and then you will curl it in the direction of the B vector. And once you do this curling over here, so when you do the curl, whatever is the direction of your thumb, the direction of the thumb denotes the direction of the cross product. So this is how you denote the direction of the cross product. Similarly, if I take Similarly to this particular situation, if I take two vectors like over here, and in the same case, if I ask you what is the result for B cross A, now in this case, your first vector is B vector, so you have to place your fingers in the direction of B vector, and then you curl towards the A vector, right? But when you place your arm or fingers of your hand in the direction of B vector, you cannot curl it in the opposite direction. So what do? We have to change the orientation of the position of the hand, and we have to place our hands somewhere over here where I will put my thumb in the bottom direction, right? So when I do this curl over here in this direction towards A, right? So I will see the thumb will point downwards. So this will denote the direction of B cross A. Now what is very interesting to note over here is that what you observe is that when you do the cross product, you see that when you just change the order of the multiplication, when you just change the order of multiplication, you see that you get a totally different vector because the direction is different. You might have the magnitude as the same, however, the direction differs. So whenever this kind of situation occurs where you have a direction is different, however, the magnitude is same, you have a different vector. Therefore, so from here, a very important conclusion can be made that A vector cross B vector is not equals to B vector cross A vector. However, if I'm interested to only the magnitude, then A vector cross B vector magnitude is basically equals to B vector cross A vector magnitude. Is this part clear? Alright, so by magnitude, this particular thing is equal because the angle is the same, but that vector direction differs. So therefore, the vector result is different. The magnitude remains the same, the vector result being different. I hope this is clear to all of you. So please let me know if this part is clear or not. Tejas, is this part clear? Is this part clear to all of you? If you have any question, please let me know in the live chat so that we can discuss over it. Now I know that this is all the basic part and you must have seen these kinds of parts in your physics, especially in the basics of physics. So you must have covered these particular things, right? However, to understand the geometrical understanding of what do we mean by when we take a cross product, let's try to see. Similar like we have seen in case of scalar product. So if I talk about the the geometrical interpretation of of cross product. So let me discuss about as the geometrical interpretation of cross product. So what we actually mean when we do a cross product, right? So if I talk about the geometrical implementation or representation of this can be given simply as, so let us again take a parallelogram. Okay, so if I take the parallelogram where the two adjacent sides denotes A vector and B vector, right? Now, when I do the cross product, I will have a vector which is out of plane and it is perpendicular to both the vectors, right? So let me first finish the parallelogram over here and name the vertices. So let us say this O, this is point A, B, and this C, right? And this particular angle is given as theta, right? So I have this following references. Now, when I project this particular line, and this is my perpendicular projection. So in this particular reference, in this particular triangle O, let us call this as D. So OCD in this triangle, if I ask you that what is the sine theta value? So in this right angle triangle OCD, the sine theta will be equals to CD upon OC. CD upon OC. Now the CD is nothing but the perpendicular on of the or the distance between the parallel sides. Now, why the distance between parallel side is important? So let's try to understand. So if I ask you another question regarding this, so if I ask you the question of the area of the parallelogram, if I ask you this question of the area of this parallelogram OABC, what I'm going to write over here is that generally the area of the parallelogram is given as the base multiplied with the height, right? So if I consider my base as the a vector, so it will be just mod of a vector, and the height will be just something CD vector, CD distance, right? The CD length. I'm only interested into the area thing. So right now I'm representing area as a scalar quantity, okay? So the scalar result will be mod of A times the CD distance, right? Now, this CD distance can be replaced from here by OC sine theta. So if I look at CD over here, so this is basically going to be OC sine theta. Now we know that OC length is the magnitude of B vector, and that I can write something like this. Now, if I replace with the definition of A vector cross B vector, so from the definition, we know that A vector cross B vector is given as mod of A, mod of B. So I'm only interested in the magnitude part right now. So multiplied with sine of theta. So if I just replace this expression for sine of theta, this will be mod of A cross B divided by mod of A and mod of B. So what I'm going to do over here is that I'm going to replace this expression of CD and sine theta with this particular expression. All right, so if I just put in over here, my value of CD will turn out to be A vector cross B vector mod of it and whole divided by mod of A vector, whole divided by mod of A vector. So what I'm going to do over here again is that now in the area of parallelogram, now finally the expression of area of parallelogram, this particular parallelogram CB or OABC is going to come out as just A vector cross B vector and mod of A. So when I'm able to find out, so with this particular formula, what I observe is that the magnitude of A vector cross B vector is nothing but is simply as the area of the parallelogram OABC. So the area of this particular parallelogram is simply given out by the magnitude of the cross product. Now, by using certain more properties of our basic geometry, so if I just plot a diagonal over here, so when I drop a diagonal, what I observe is that I divide this entire area into two equal regions or the area of the triangle, right? So from here I can also obtain another important relation, that is that if I'm interested to only find out the area of the triangle OAC, then that will be basically half times the area of the parallelogram OABC, and that is going to be half times mod of A vector cross B vector. So the area of the triangle can also be given as half times the cross product magnitude. So area of any triangle whose corresponding sides are given as A vector and B vector. I hope this discussion is clear. So from here, another more important result can be obtained for the area of the triangle as, so if I have, let us say, then I have the triangle which is given as A, B, and C, right? Now, if I say that Uday Gaming, hi, if I say that if A vector, B vector, and C vector, small c vector, denotes the position vector of this coordinates of the triangle over here, then in order to find the area of this triangle in terms of the position vector, so these are nothing but the position vector, so which I have already discussed in our previous classes. So from here I can also find out the angle between the vectors by doing a simple cross product by first of all finding the vector which represents the sides. So if I take one of the side as BC and another side as BA, so this particular side can be given as C vector minus B vector, and this can be given as A vector minus B vector. So from this particular result, if I try to find out the area of this particular triangle ABC, this can be given as half times the mod of, so we will have C vector minus B vector and cross with A vector minus B vector. So then if I try to find out this expression, I will get the area of the triangle ABC. So let's try to simplify this expression and we'll obtain a very general result in terms of A, B and C as follows. So there will be half times mod of. Now if I perform this cross product over here and step by step I have to do it. So first of all it will be C cross A vector minus C cross B vector minus of B cross A vector and then plus of B cross B vector, right? Now interesting part over here is that whenever I have parallel vector or whenever my theta is 0, so generally when I have a cross product with a vector itself, it is basically having the angle theta as 0 degree. So when my angle is theta is 0 degree, I will have the sine theta is equal to 0. So this particular cross product will vanishes to 0. Therefore, I am left out with the result over here, which I can simplify. So I am just changing the order. So when I just change the order of the multiplication, I just do a negative of it, right? So I can write this particular part as A vector cross B vector plus B vector cross C vector plus C vector cross A vector. So this is the more general result. So this is a quite a general result which is very easy to remember. So this will give me the area of the triangle ABC where my A, B, C are the position vectors of the coordinates of the triangle. I hope this is clear to all of you. Is this part clear? Right. So I assume this part is clear. So with this part, we can comfortably say that we have understood on how or what is the geometrical implementation or representation of a cross product thing. So generally when I talk about cross product, the first and foremost thing that should come into mind, the magnitude of the cross product denotes the magnitude of the area, right? Also if I'm interested to find out the area vector, then I would directly say that it is just simply given by the cross product of A cross B. So the A cross B thing would definitely give me the entire area with the area vector, because we have seen that area vector is either perpendicular or out of the plane. So if I just do the A cross B and do not take the mod of it, it will give me the area vector. However, in general results, we are more interested to find out the scalar value or the magnitude of the area of the parallelogram. I hope this is clear to all of you. Is this part clear? So please let me know if you have any questions so that we can discuss about it. Okay. If you have any questions, please let me know so that we can discuss on it, and you will be having ease when you are basically going to solve questions. All right. So with this, let us also try to understand how do we perform the vector product in terms of the components. So if I have my A vector given as A1 I cap, A2 j cap and A3 k cap, similarly my B vector is given as B1 I cap plus B2 j cap plus B3 k cap. So in order to perform the A vector cross B vector, now we have seen the result that whenever we take the cross product with the vector itself, the result is 0. Right. So I cross I, j cross j, and k cross k, this is going to be 0. However, there is a rule. It is not a rule, it's just like we are using the right hand thumb rule. So whenever we do the uh, cross product of I cross j, the result is k. Similarly, when we do j cross k, the result is I, and when we do k cross I, the result is j. So this is how you have to remember the expressions. Okay, so this is how we do the expression because we are following the right hand rule, right? So if I try to apply this particular concept to this particular problem, we will see that the result of this cross product, when we do the cross product component wise, so I'm going to get a1 b2 minus, so I will have, oh sorry, so for the I cap component, if I do this cross product thing, so I will get a2 b3 minus a3 b2. That will be my component that will come with I cap, minus j cap component will come as a1 b3 minus a3 b1, and similarly k cap component will come out as a1 b2 minus a2 b1. So if you perform this product component wise, so you will definitely come out with this particular expression. Now if you look at this particular expression, it is very likely that we can write this expression in terms of a very simplified notation, that is a determinant form. So we can write this as in the simple determinant form, something like this, where my rows denotes the component or the individual component of my vector. Alright, so this is going to give me the result for how to perform the cross product. So this is the result of cross product. Alright, so this is how you can perform the cross product in terms of the vector components. Alright, so with this part, we come to the end of today's discussion, that is going to be the basic part of cross product. So we have tried to explore the ideas of vector dot product and vector cross product, right? So we try to understand the two different concepts of vector multiplications, and we saw certain properties and applications of those two products. So in the next class, we're going to solve some varieties of problems that is going to represent how to perform the product of two vectors. And we're going to see that in the question, by solving the question or by solving the vector equations, will require the need of doing the dot product or doing the cross product. And with that, we'll see varieties of problems had been asked so far in the previous JEE Mains and JEE Advanced paper. So definitely in the next class, we're going to look into that particular aspect. So if you're in this particular platform, please like, share and subscribe this particular channel, and also hit the bell icon so that whenever we are live on this particular platform, you directly get a notification and you can attend this particular lecture just by sitting at your comfort of your home, and you can achieve these good lectures which will help you to prepare for your competitive examination. And also if you are also a CBSE or any board student who are basically appearing for the class 12 board examination, this lectures is going to be sufficient to help you out for your board exam preparation as well. So with this part, let's end our discussion over here, and I hope this particular part gave you an immense clarity on the basics part. And then in our next class, when we solve questions, you will see that there will be lot of applications where we can use this particular ideas, right?